guys, first we thank God for the opportunity for us to come and be able to do some mathematics. And so therefore guys, let's start by reading the question. Show that this is the double integral and the results should come to this. So guys, we start doing the problem. I've already written it down here guys, and we can start solving the problem. Guys, we are going to first of all integrate with respect to y. That is from square root of x to 1, and then we integrate with respect to x from 0 to 1. So guys, I start now doing the problem. I integrate from root x to 1 of, that is y, all over square root 1 plus x squared dy. So guys, this is now going to be equal to, we can move out the square root because we consider this as a constant. So we shall have 1 all over square root 1 plus x squared integral from the square root of x to 1 of y dy. So guys, we are going to have here 1 all over square root 1 plus x squared. We integrate y, guys, we get y squared all over 2. The limits are square root of x and 1. We can now insert our limits. We get 1 all over square root of 1 plus x squared. Here we are going to have, we can put 2 right there, 1 all over 2, we can put it there. So that now guys, we have 1 minus x. That's when we insert 1, because 1 squared is 1. And then we have square root of x, you get x. Our 2, I've already put it there. So guys, we are going to have our answer as a half. Can actually put a half outside, so that we have 1 all over square root 1 plus x squared plus, this one is going minus x all over square root of 1 plus x squared. So guys, from there we come and integrate with respect to now x. Yeah, integrating now with respect to x. That is from 0 to 1. So we can put a half outside, integrate from 0 to 1, 1 all over square root 1 plus x squared minus integrate from 0 to 1. That is, we have x divided by square root 1 plus x squared. And here we have, guys, now we are doing with the reference to x, using the y variable, the x variable. Here we have dx, and also here we are doing with dx. And from there guys, for the first one, the integral for first one, guys, we are going to have a half. This This one gives us sine hyperbolic. The integral of that is sine hyperbolic inverse x. So guys, we are able to find the first one. That is from 0 to 1 here. And so guys, we now come and look for this, the integral for that. Guys, remember that this one is supposed to be, the 2 is supposed to be outside there. This is now minus. You can say this is now, the limit is from 0 to 1 minus the integral of 0 to 1 of x all over square root 1 plus x squared dx. So guys, we are now going to deal with this integral right here. So guys, we come to this other step. Guys, we can leave behind this and then we shall come back to them later. So I will do this integral while leaving this one, the whole of this behind. So I'll say integral from 0 to 1 of x all over square root 1 plus x squared dx. So guys, with that one, I can say let me say let x squared be equal to u. So that guys, we have 2x is equals to du all over dx. I can bring the dx this side. So that guys, we have, that is 2x dx is equals to du. So guys, from there we come and write, this is now going to give us, we convert that, we replace, that is we replace for u and we replace also for dx. Because of that guys, we are going now to introduce 2 at this position, and by introducing 2 we need also to divide. So guys, we shall have integral from 0 to 1. I write here half, and by writing a half there, I write here 2x dx all over square root 1 plus x squared, like that. Guys, I have introduced these 2 because of the way, as you can see here, we have 2x dx is equals to du. So I have opted to introduce a 2 here, and because of that guys, I have also to divide it by a 2 so that everything remains the same. And so therefore this is now going to be equal to integral, that is from 0 to 1, we have a half here. Then guys, this is now going to be 2x dx equals to du. I replace 2x dx. So this is going to be now du all over, here I can use the blue biro pen, all over square root of 1 plus x squared. The x squared is supposed to be u. So with that one guys, we are going to have a half. We now integrate 1 plus u. This is the same as 1 plus u raised to negative a half when it is at the top here. And so guys, we are going to have, when we integrate that, is going to be 1 plus u raised to a half, and then all over 1 over 2. So 1 will be down here, and then we are going to place our 2 there. So guys, this is now going to be, we can cancel the 2. So we are left with 1 plus u raised to a half. All that, guys, and the limits are 0 to 1. So guys, we are going to have, when we put 1 here, we are going to have 2, that is square root of 2. And then when we put 0, guys, we are going to have minus. Now when we put 0 there, but before, guys, we do that, we can, obviously, guys, we are going to change. We are going to change, so I can cancel this. We first of all put x squared here, because u is equals to x squared. We will have, this will be equal to, or it's supposed to be, 1 plus u. The u is going to be x squared, like that. Here we have a half, and then this, the limits are going to be from 0 to 1. So guys, now we can put our limits there. So we shall have, if you put 1 here, you shall have 1 plus 1 is 2, and then 2 raised to a half, that is square root of 2. Guys, now we can put the 0. We shall have minus, when we put 0, we have 1, and then we have, this is going to be square root of 1, which is the same as 1. So guys, we write like that. Guys, from there we go back to where we were. We were at this position, whereby now we come and write this. So we shall write our equation then is going to be equals to a half. Then we can put that bracket, sine hyperbolic inverse x, limits being 0 to 1, minus, guys, this is now going to be square root of 2 now plus 1, like that. Finally, guys, we can now replace our 1 and 0. By doing that, we shall have a half sine hyperbolic of 1 will give us, we can write it there first, sine hyperbolic of 1, also put in that bracket, minus sine hyperbolic of 0 gives us 0. So we shall do away with that. So this is minus square root of 2 plus 1. And so guys, now this becomes our solution. This becomes our solution, even as we can see here, right here. So as you can see, we have already proved. And thank you guys for listening to me. Bye bye.